Hello everyone. Today we will review the solution to the cash exercise, which is the second exercise for the CS50 computer science class given at Harvard. This is my wife's solution and she did a really good job.
Hello, hello.
She's here with us today. Hi my baby. And alright, let's first review the algorithm. Let's see how the solution works, and then just like we did last time, we will see if we can make the code a bit better.
He's gonna work his magic.
Right, so I think last time I emphasized how important it is to have descriptive variable names, and here kudos to my wife because she has very good names. This function quarters to give is very explicit. I understand that it's going to tell me how many, because it's an int, how many quarters to give given an amount that is owed.
So I was actually guided by him because he explained that using words like calculator, etc. is not efficient, because once you have heaps and heaps and heaps of code collectively, you'd be wondering what kind of calculator is mentioned in this variable. So it's handy to have distinctive names.
Exactly. You don't want to name it calculate quarters, for instance, because every function calculates something, right? So this
Can be confusing.
This word, these full 9 characters are not useful. You might as well just call it quarters. Okay, so what about the algorithm here?
Just before you start, I have submitted my assignment already, by the way, before he does this, in case any of you ever wonder if I submit his version or mine. I do mine and then he reviews mine.
Yes, no cheating here. Alright, so first we prompt for the amount that we owe using the getInt, and very standard in this class, do while loop. It will keep asking, because there's a while here, it will keep asking until the amount is positive. Okay, so if it's negative, ask again.
Yes.
Yeah? Yeah.
Until a valid input is put in, whether it's characters or letters, it won't accept and it will ask again. And that was as per the assignment, yeah.
And then we compute the numbers, or the number of quarters that we want to give back, okay, and we subtract the value of those quarters from the amount that we owe. Then we compute the number of dimes that we want to give back, and we subtract that amount from the amount that we owe, and so on and so on. The question can be, okay, do I have an optimal solution if I first compute the quarters that I want to give back and I make that the maximum amount of quarters? Okay, so what happens if I compute first the maximum amount of quarters I can give back and I give this back, and then I compute the maximum amount of dimes I can give back and then I give this back, and so on and so on? Will that give me an optimal solution? Or would it give me a better solution if I gave less quarters and more dimes, for instance? Well, it depends on the value of the coins that you have. And here, because we have 25, 10, 5, and 1, there's a reason why the government has chosen these values. It's because you can use a greedy algorithm to solve the problem of computing how many coins, of computing how to give change back to someone. And the greedy algorithm is exactly what I just described, meaning find a subproblem and maximize on that subproblem. So just give as many quarters as you can back, and then give as many dimes as you can, and then give as many nickels as you can, and this will give you an optimal solution.
Basically giving as less coins as possible.
Right, exactly. The optimal solution here is the least amount of coins that still give you the total amount owed.
Yeah.
Okay, so let's see how to compute the number of quarters to give back. Well, if I owe you, let's say, I don't know, 55, okay, 55, what I can give you quarters, I'm going to give you quarters. So 55 is more than 25. Here I have 55, it is more, meaning I'll give you one more quarter, and if I give you one more quarter, I owe you 25 less here. On the next iteration of the loop, I am left with 55 minus 25, which is 30. And I'm going to give you one more quarter and deduce the value of that quarter from the amount that I owe you. On the next iteration of the loop,
you're left with 5.
I am left with 5 exactly. And because 5 is less than 25, the loop will not be executed. We will jump to the return statement and we will return 2 in that case. All right? And this is how you compute the number of quarters to give back. Just reduce by 25, increase quarters by 1, reduce by 25, increase quarters by 1, rinse and repeat until you can't do it anymore. It's the same algorithm for the dimes, except it's 10 by 10, and the same algorithm for the nickels, except it's 5 by 5. Right?
So
and this
here the 5 will go in and we'll be left with none.
Right. If I were to run the program with 55 as input, I would start with the quarters to give here. Amount owed would start at 55 here. Okay. I enter here. I execute the loop once with 55, another time with 35 exits. Okay. I get my number of quarters. Here it's 2 quarters to give back, like this. So here I get quarters equals 2, and amount owed goes from 55 to 55 minus 2 times 25, which is 5, right? Then dimes, here I enter the function with 5. I go to the dimes function. Here I have 5.
It won't go through.
And in the while loop, it happens that 5 is not bigger than 10, so the loop is skipped, and I return 0 here. Okay? So here I still have 5 because 5 minus 0 times 10 is still 5, and so on and so on. Okay? When I enter the nickels amount, I still owe you 5. It will compute that it can give 1 nickel back, and we will have 5 minus 5 is then equal to 0. Okay, so here we go from 5 to 0, and the solution is done. Okay, we have 2 quarters plus 1 nickel.
3 coins back.
Which is 3 coins back. If I run the program, okay, so here I have my terminal at the bottom. I can compile the program using make cache. It works. And I can run the program using /cache, right? What I like to do when I program is I do make cache, and on the same line I put end like this, and I run the program, okay? Which will do both at the same time. If there is an error during the make, the cache will not run, okay? And only executes if the left-hand side returns without any errors. Amount owed, let's say I owe you 55.
3.
It returns 3, which is exactly what we computed before. Okay, let me remove all the comments.
How are you doing that?
Control Z.
Oh, I was like, are you jumping somewhere?
I'm just Control Zing around.
Okay.
Okay, very beautiful solution. Optimal algorithm. There is nothing to change for the algorithm. Now, what we will do is we will try and make the code, let's say, a bit more beautiful or a bit terser by removing duplication. Okay, duplication can happen if you copy paste code. It can also be structural duplication, meaning it's not exactly the same, but the structure is sufficiently similar that you can merge functions together, or you can replace blocks of code by, let's say, a loop or something like that. Here I have 4 functions and they look very similar. You can see that the structure of the code looks the same. We have an int declared, we have a while loop, we have an increment, and we have a subtraction. And here same, int, while, increment, subtraction. Okay? How do I change these functions so that they can be merged into one?
Well, the values are different.
Exactly. First thing to notice is that the values are different, 25 and 10. And second thing to notice is that the name of the variables are different, but that's it. The structure is the same. I don't have to change the order of statements or anything like that here. Okay. this value 25 and 25 and this value 10 and 10, I can pull them out of the function by introducing first a variable. Okay, so what is 25? Well, 25 is the value of the quarter, right?
Right.
Let's call the variable coin value. Okay?
Okay.
Set it to 25 here and use that variable
Instead of the 25.
instead of the value, instead of the 25. And here I will do the same thing. I'm going to declare a variable and name it coin value 2. I set it to 10 this time, and I use it instead of the value here. Okay? And now I don't have any values between this block and this block that are different.
They're basically the same.
They're basically the same, exactly. Let's make the variable names the same so that we can really see. Actually, now the structure is exactly the same for both these snippets, but just for the sake of clarity, we're going to make the variable names the same. Here I have a quarter that is used in 2 locations, and here I have a dimes that is used in 2 locations, but the locations are the same. I can just rename this, and I can rename it N coins. Why N coins? Because N coins stands for number of coins. Okay? And in the quarters to give, I want to compute the number of quarters, and a quarter is a coin, right? So N coins is equal to 0. Here I increment the number of coins, and here I return the number of coins. Clear?
Yeah.
Okay. I do the same thing here. Dimes I rename to N coins, and I just return N coins, increment N coins, and then return N coins. Okay, I just had a variable and I renamed it, and it just happens that these 2 variables now have the same name, but they're not the same variables, okay? This variable is only accessible within the function block and not outside the function. And this other variable has the same name, but it's only accessible within that function block, okay, between the curly braces. Every time you declare a variable inside curly braces, it is only visible inside this block, this curly braces block.
Yeah, it's not declared outside of it.
Now, because this is the same as this, I know I will be able to merge them, okay? But before I can merge these 2 functions, I need to get rid of that line, because that line is different between the functions.
You need to bring it out of the curly braces.
And exactly, if your only lines that differ between functions is a variable, you can pull the variable outside the function, okay? You make it, how do you pull it out of the function? You make it an argument. So here you put coin value as argument to the function, and you know that you will need to call the function with the value 25 here. So let's go to quarters to give. Up top, I'm adding the second argument, coin value. And here when I call the function, I add the coin value for the quarter, which is 25. Okay? And I can do the same thing for the dimes. So I'm going to pull coin value out here in the argument. So I don't need this anymore. I don't need this anymore. I go in my dimes function. I change the prototype here.
The coin value.
And when I call the dimes to give here,
you add another variable.
I add another variable.
Argument, sorry.
Yes, you're right. I add a second argument to the dimes
Yes.
function. All right, let's run the code and let's see if it works. Make cash, run cash, amount owed 55. I still have 3 coins, everything
Okay.
compiles, everything is fine.
Nothing's broken.
Okay, we didn't break anything, and now we have 2 functions that are exactly identical. Okay, it's a copy paste. So what I can do is I can use one instead of the other. Okay, so quarters to give, dimes to give, because I'm going to merge them, I'm going to give them a better name. And I'm going to call this, let's say, coins to give. Okay, instead of quarters to give.
Okay.
Now I can remove the dimes to give function here, and I'm going to call the coins to give function instead. So instead of quarters to give, coins to give, instead of dimes to give, coins to give. Okay, here I need to update my prototypes, and I don't need this one. Actually, it's the same for nickels and it's the same for pennies. So I'm going to remove it from here, and I'm going to use my new function coins to give with the value of a dime.
Wow.
Sorry, with the value of a nickel here and with the value of a penny here. Okay, if I run the code again, it compiles and it gives me the right value.
You just took off like a good 10 lines.
Actually, we took off 28 lines. I think it was 68 to start with.
Wow.
Not bad, huh? Okay, and this function is ready. There is nothing more we can do to it. And we could stop there. Okay, but if you know arrays, or if you are curious about arrays, we can use an array here to merge these blocks of lines together. Why? Because they are structurally equivalent.
Yeah.
If you look at the type int equal function minus times, int equal function minus times, and one more time, int equal function minus times. It's the same structure, just with different names and different values. And when you have the same structure, you can do exactly what we did for the function. Okay, you make them baby step by baby step the same, and then you merge them together.
Okay.
Let's do that now. Okay, first I have values, same as before. I want to pull these values into a variable. All right, so because
introduce a variable,
because I'm in the same block here, if my variable has the same name, I cannot declare it twice. Okay, I can't type int a and then int a again. That's not going to work, right? So what I'm going to do is I'm going to declare the variable both first, coin value like this, and now I can reuse that variable for every block of line without having to redeclare it.
Okay.
Now the coin value here is 25, so let's go. Coin value is equal to 25, and then just replace 25 by the variable. All right, and here I do the same thing. Coin value is equal to 10, and replace 10 by the variable.
Okay.
Okay, now because we're going to use arrays and because arrays are new, I'm going to do it for the next two lines. Okay, we're just going to take a bit of time. So coin value is equal to 5 here, and I can replace it in there, and here coin value is equal to 1, and I'm going to replace it in there.
Semicolons.
And I'm missing semicolons because I have not programmed in C in a very long time. Thank you. All right, let's run the code. It still works. I just pulled the value out in a variable. There is no big change here. Right, now what is the next thing to do when you want to merge blocks of code? You pull the values out, and then you make the variable names the same. Okay, so here I have a quarter variable and here I have a dimes variable, and they are used in exactly the same way, but they have different names. So what I'm going to do is I'm going to give them the same names. Let's declare a variable here and call it coins. Okay, now the coins I can use instead of quarters. Here I have quarters, I use coins instead, and everywhere where I have quarter I use coins. Okay, but wait.
At the bottom.
But wait, at the bottom quarters is used. Now, if I overwrite the value of coins here by assigning it here, I will not be able to use it at the bottom. So in order to do that, I'm going to use it here immediately. I'm going to take this plus statement and just break it in several statements. Okay? So that we don't get confused, let me cancel the change for coins. Okay, I'm just Control-Z, I'm back to quarters here. Okay, we still have the variable, we're going to keep it there, and we're going to use it later. Let's break this statement first. Here are how I'm going to do it. Total coins, I'm going to declare it and assign it in two different lines. Okay, this code is the same as what I had right before. And now I'm going to accumulate in the total coins, but on different lines. Okay, so I'm going to say total coins is equal to total coins plus quarters, and then I remove this. Okay, and then total coins is equal to total coins plus dimes. Total coins is equal to total coins
Can you do a
plus nickels.
equals?
Yes, you're right. We can do a plus equal. That would also work. Okay, let me. Right. So now what you have here, we have. You're right. We're gonna do this.
Yeah.
We have the same statement as before, but broken into several lines. And like she said, the smart student, we can use this shorthand syntax of plus equal, which is actually more readable once you get used to it, because here it says I have a total count variable that is set to 0 initially, and I'm adding quarters inside to it, I'm adding dimes to it, I'm adding nickels to it, and pennies to it, and I'm storing everything inside that variable. Now that I have this statement broken down and that the variables are used on different lines, I can reorganize those lines and pull them up. So I'm going to pull the declaration of total counts up.
You can put it right on top.
And we put it on top up there. Then the quarters one.
Put it in the quarters section.
Exactly, we put it in the quarters section here. The dimes one, we put in the dimes section. The nickels one we put in the nickel section, and the pennies in the penny section. Okay?
Yeah.
Any questions?
No.
Alright. Now that I have done this, I am ready to go, because the quarter variable is not used outside of this block. Okay? It's not used here anymore. Right, so what did we want to do? We wanted to rename the variables in that block so that they have the same names as the variables in that block. Okay, and here the only names that are different is quarters and dimes. I have an empty coins variable here that I can use. So instead of quarters, I'm going to use the coins variable. I'm going to use it here and here. Okay, and I'm done for that block. Now next block, instead of the dimes variable, I'm going to use the coins. Sorry, I'm going to use the coins variable, and I use it here and I use it here. Okay, and it's the same for the two other blocks. Let's just take half a second and do it. Instead of nickels, I name it coin, and instead of pennies, I name it coins. Good, and now you can see that either for this value here and this value here and this value here and this value here, these three lines
Are the same.
are copy paste every time. They're exactly the same.
Right.
Right, I'm almost ready to use a loop to repeat these blocks of lines. Okay, what I need is I need to store this sequence of values 25, 10, 5, and 1 into something. Okay, and there is a type in C
Array.
that gives you a sequence. It's an array. Okay, so here's how you declare an array. You want an array of int, so you start by typing int, then you give the array a name.
Values.
We can name it values, yes. Okay, so int values, and then here these brackets to say it's an array. And then you put your sequence here. So the values are 25, 10, 5,
1.
and 1. Okay. Now, I can access the 25 value by typing values 0. Okay, value 0 is the first element, so it's 25 here. And I can access the second value 10 by typing values 1. Okay, values 1 is 10. And so on and so on. This is values 2 and this is values 3, and then we're done. It's the end of the collection. Now, because value 0 is 25 and here I have 25.
But wait, don't you want to maybe make it so that nobody can change it, so it can't be changed accidentally?
You are right, because these values are constants, they're not supposed to change in the program. I can make my program clearer by saying that they are constants, okay? By making it a const, not only no one can change the value, so I know I won't have an error later in my program, but it's also documentation. It also says, hey, these values, they're not going to change.
Yeah.
It's read-only. Very good remark. Smart cookie.
So the quarters, dimes, nickels, and pennies are all going to stay the exact value throughout the program, throughout the
execution of the program. Exactly.
Yeah.
These entries here will keep their values during the whole lifetime of the program.
Okay, good.
Now this 25 is accessible through this syntax value 0, and then this 10 is accessible through this other syntax values 1. Okay, what I'm going to do, because I want to merge these statements into a for loop, I'm going to use the arrays here and here and here and here instead of the values. So value 0 goes into 25 here. Okay, and then values 1 goes for the 10 here. Okay, and here we said values 2 is 5, right? So here I can type directly, I can type values 2. Okay, and values 3 will be this value here, which will be 1. Okay,
3.
Sorry, value 3, you're right. All right, so now
Is this executable?
now let's check if our program compiles and runs. So we can do a make and run, and we have
An error.
a syntax error somewhere. So let's look at it. Use of undeclared identifier value. Did you mean values? Yes,
Okay.
because here we need an
Yes.
S. Okay, let's try again.
Yes.
Make and run, amount owed 55.
Got it.
We still have 3 coins. It compiles and runs. Everything is good.
No.
Alright, now that we have these statements, you can see that the only difference between these groups of lines is that we have a sequence of indexes. Okay, when you have a number inside the square brackets, it's called an index. And the only difference is the indexes, they go from 0 to 1 to 2 to 3.
They're incrementing like it does in a loop.
They are incrementing, exactly. And actually, you know what? It's a very good remark, because just for the sake of teaching, let's create a variable. Let's call it I. Let's set it to 0, and let's put it in there. Okay?
Yeah.
Now, I've used I, and its value was 0. The code is the same, right? I had 0, I have 0. Now what I'm going to do here is, here I'm going to increment the variable. Now I is 1, right? And I need a 1. Well, I can use I here. Okay, and then here I'm going to increment the variable again. So now I is going from 1 to 2, so I is 2. And I need a 2 here, so I can use I again. Okay, and I think you see what this is headed. This is headed that I'm going to increment the variable again, so now it's 3. And I need a 3, and I can use I here. And here I have an exact copy-paste of my code. There's nothing different, not even a sequence of indexes, nothing. Okay? And when you have copy-paste of blocks like this, and you want them to execute 4 times, you can use a for loop. Okay, so this I here that I incremented 4 times, I'm going to use the for loop to increment it instead. So how do you write a for loop? Well, you write for int I equals 0, and then you need to know how many times you're going to repeat the loop. You want I to go from 0 to 1 to 2 to
less
3.
than 4 times.
So it has to be less than 4. Okay, 3 is the biggest value it can take. And between every iterations, what do? We do I++, like this, which is what I'm putting here. Close the loop, add a brace, and take your block of code and put it inside the loop. Like this, okay? And now I can remove all of this.
Oh, wow.
All these lines of code will be executed by the loop.
20 lines again.
And now we have 40 lines. We've saved a few lines, but more importantly, we've saved duplication. Okay, we had structural duplication, and we've pulled variables out. And the code is shorter. There is just one more thing to do here, and then we're done. It's to pull the variables declaration, the variable declarations, down to the most restrictive scope. So what does that mean? It means
Inside the curly braces.
that every time you have a set of curly braces like this, you're creating what we call a scope. Variables that are declared inside that scope will not be visible outside of the scope, neither before nor after. Okay? The coin value variable is used inside the scope, but not outside that scope. So I don't need to declare it here. I can declare it
Directly
here
there.
directly. And I've saved one more line.
Coins as well.
And it's the same for this coins variable here. It's only used inside the scope of the for loop, so I do not need to declare it outside of it. And now we're done. That's it. We're down to 38 lines, and we have no duplication in the code. We can run and make and run, and convince ourselves that the code works.
That's great.
All right. I guess we'll see you guys for the next exercise. Leave a comment if you have any questions, or if you have any complaints about the way that we filmed that video. I'm happy to improve it and make it more accessible for you guys.
Thank you for watching and subscribe. Bye.
And don't forget to subscribe. It's important.